Hello friends, we are back with another new video. This is all about mangoes. The unripe mangoes, when they are stored badly, and this is around fruits, the fruits are also stored badly, and if they are stored badly, so what happens? The mango is in front of you. This is the condition of the mango. So what happens when this mango is stored badly? So here we are going to, this is the condition of the mango. You can see in the camera, this is the condition of the mango. So this is the black mold formation, the brownish mold formation in the mango, in the camera. This is the condition of the mango. So we are going to excavate the fungus. It has been fungus affected. So we are going to excavate this fungus, petrified, and we are going to excavate the fungus with the help of a scalpel. Our basic tools, the scalpel and a forceps. This is our forceps and this is our scalpel. So we are going to put a blade on the scalpel and we are going to excavate the fungus. Actually, what happened, I have wrongly I have taken out the blade from the package. Should not be done. This is very sharp. This is a very sharp blade, as you can see. This is a very sharp blade. So it is a very sharp blade. You can see in the camera. So this is a very sharp blade. So this you need to be very carefully handled. Otherwise, any moment you can cut everything. So cut your body. So this is a surgical scalpel. So again, it has been wrongly placed. So this is the correct orientation. You have to orient the handle properly and you have to place. Otherwise, you'll be in trouble. Placed with their hand and just on the head of the forceps, just put down the blade. So this, anyhow, this you saw in the now the scalpel is ready. So now you are going to excavate the scalpel, excavate the fungus. So we will give you an incision. It's a big incision over here, as you can see. Incision is there. So this is a transverse incision and we are just opening the skin, and you can see everything is brown inside. So this is a brown mold, you can see in the camera. So this is a brown mold. So this is a brown mold and we are going to extract from inside. So all the thing is petrified. So we are going to extract with the help of a forceps. So this is a brown mold, brown fibrous mold. It has become very fibrous. So it is not going easily. Anyhow, not very much needed because this is a very bad fungus. So we are going to take only little much. So this is enough. So this is enough. So this is the, and we will throw out the rest of the mango and also the skin. This is the rotten skin. We are going to throw it out. So our extraction is complete. Now we are going to put the culture media. Now this is a this is a sodium acetate differential agar. So we are going to put the sodium acetate differential agar. Now we are going to take out the pipette and now we are going to So this is sodium oxide. Up to the 0 mark. Okay, now it is done. So the sodium acetate already it has changed the color due to the fungal reaction. It has changed the color from green to yellow. Already the fungus is active. So we are going to cork it and put it in the incubator. So this is the condition of the fungal matter in the sodium acetate differential. So these are we are going to sorry, excuse me. This is how we're going to differentiate and even to study under a microscope after just 5 days or 3 or 4 days. We will just see after 3 days. So because this is a very profuse action, so we are going to inspect after 3 days. So let us see what happens after 3 days under microscope. This we are going to investigate this fibrous structure of the fungus. Maybe this is fibrata or maybe something like that. So let us see. It should contain, it's a fruit fungus, so it should contain pathogen, the mycotoxin, the known mycotoxin, but maybe something different. So actually what I want to say in this video that what a scientist proposes, the subject disposes. So that is a very known victim to us that according to the subject and the subject and scientist relation, that when a subject proposes, a scientist proposes, sometimes the subject disposes. So let us see after 3 days what the subject proposes and some scientist has to accept. So let us see after 3 days. So we'll be back after 3 days. Hello friends, we are back after 24 hours. As you can see with this mango mango fungus, or rather this mango splex, and as you can see is a very big lump has formed, and it is a lumpy fungus, and after for 24 hours, almost 24 hours, it has given us a very big development. So we have to separate this and we will be watching under TCM 400 microscope. So this is a very heavy fungus. It is a very heavy fungus, heavy disposition. We have to morcellate it and then we can begin for further investigation, because this is so heavy that it will just close the microscope, so we won't be able to see anything. No structure will be defined, so we have to go for morcellation. So after morcellation we will be able to see the fungus. So let us begin with this morcellation process, and after the morcellation process is ready, we will be going for further visualization. So in the next part of the video we are going for the morcellation and then we will go for investigation. So be with us for the later parts of this video. So this will be going to be very interesting. Maybe this is going to be a very interesting thing, because mangoes, what happens when a mango is rotten. So what we see under the microscope when a mango is rotten, so what kind of fungus it is. It is a very heavy looking, it should be Candida fungus. It can be Candida albus, it can be Candida negros, it can be Candida purpura, or maybe anything. So this is a Candida fungus. So let us see what it is. So which one it is, let us see. It may be Candida negros because it is almost is a lump and blackish formation. So it may be Candida negros. So let us see what it is. So we are further going to extend this video for morcellation and tissue morcellation, and then we are going to investigate under the TCM 400 microscope. So let us begin. Hello friends, so we are back after morcellation. I have actually deliberately I have isolated the morcellation part. I have deleted the morcellation part, so that will taking time. So here is the morcellation ready. You can see in this camera also. So here in this camera also you can see the morcellation part is ready. So this is, now we are going to look at this under TCM 400 microscope. Here also we are going to dilute, we are going to dilute the morcellation and dilute the fungus, and we are going to see it in under TCM 400 microscope. So let us see whether we need to dilute or not. Then we will be deciding for the morcellation experiment. So we are going to take around 1 ml as usual. We are going to take 1 ml, and here we are going to take 1 ml, and as usual this is a very heavy fungus, so we are going to take 1 ml. So here is it, and it's a very heavy fungus. As you can see, it is sitting, so it is a very heavy fungus. We need to dilute. So here what we are going to do, we are not going to use the dextrose saline solution. Here we are going to use formol saline solution. This is another diluent or another fixative. This is a fixative also. So what we are going to do, we are going to take a formol solution. This is formol saline solution. This is a very beautiful preservative also, and also is a very beautiful diluent. So here we are going to take formol saline, so around 2 ml of formol saline solution. This we are going to make the tissues clear. So we are going to take 2 ml formol saline solution. This is formaldehyde and saline, so around 3 ml we are going to take. So 3:1. Now this is 3:1 dilution. Now this is 3:1 dilution. So let us see what is it shows. So let us see what it shows. So this is 3:1 dilution. Now the tissues are very widely visible. We can see the tissues, so they are widely visible. So this is yellowish in nature. Now the candida has become yellowish in nature. So we are going to look at the TCM 400 microscope after this dilution. You can use dextrose saline solution, or you can use dextrose physiological saline solution, or you can use this formol saline solution. Anyone you can use, because this is a diluent. Here we are using it as diluent. But formol saline is better because that fixes the tissues also. So we will be able to see no ruptures. There will be no ruptures in the tissue, because after morcellation, the ruptures takes place. Rupturization takes place. So this rupturization is healed by this formol saline. So formol saline is better than dextrose saline solution. Anyway, that you can use both of them. Any of them you can use. So formol saline solution also you can use. You can use dextrose saline solution, whatever you can use. So which is ready in hand, you can keep. You can use it. So we are going to use this already done. So now we are going to look in the TCM 400 microscope and the first inspection after 24 hours, what it looks like. After that we will decide for fluorescence imaging and all that. So let us go to the microscope and let us see. So you can see the structure of Candida nigros. So in the center of the screen you can see the structure of the Candida nigros. So it is a very difficult fibrous structure. It's a very complicated fibrous structure. You can see fibers all around, and you can see this is a very fibrous fungus, more similar to fibrata, Citra fibrata, but it is different because Citra fibrata was transparent fibers, but this is a black fiber. So this is Candida. So this is a molasses form. Molasses, a form of molasses are there. So these are the molasses of the Candida molasses. You can see in the center of the screen. This is a full screen. This is 100x magnification, but still we are trying to observe. This is 100x magnification. You can see the clearly structures of the molasses here. So this is Candida nigros. So all around is a very difficult fungus. It's a very dense fungus. You can see the Candida formation, the Candida cloud formation. You can see the microscope is focused, and you can see the Candida cloud formation. So this is the phase contrast image of the cloud formation, Candida fungus, and this is the situation. So this is all about Candida nigros. So you can see this some other parts of the slide. It is a tremendously fibrous structure, and it is very dense. And as you have seen in the other part of the video, beforehand the video, this fungus is very dense. So it is and is very densely evolved. It has also very densely evolved. You can see the structures and the spots. And these are it is also sort of a mold fungus. The group is mold actually. So this is so we are seeing the other parts of the specimen. in the petri dish. So it's a dense fungus. After 3:1 dilution also we are getting a very dense appearance under 100x magnification. So this is a very dense fungus. So these are the other parts of the specimen, and therefore it is very dense. You can see some molasses and molds of the Candida nigros, and still we are there, and you can see the branches and the hyphae of the fungus behind background. The hyphae, you can see the hyphae of this fungus. There in the left hand side screen you can see lots of hyphae are there. Left hand corner, left hand upper corner you can see the hyphae. So this is the Candida nigros, and that is our first investigation. So this is the Candida nigros, or you can see the fibrous structure of this Candida nigros fungus. This is also, you can say, Candida fibrata, looking fibrous structure, showing the fibrous structure. So this is another name is Candida fibrata. So this is the fibrous structure of the Candida fibrata or Candida nigros, whatever you can say. Both names are suggestive. So now you are increasing the magnification to see the fibrous structure inside the fibrous structure. Now this is for 200x magnification. We are going to see through it, and you can see the fibrous structure, and you are going for 400x magnification, and you can see the fibrous structure even better. So this is the internal fibrous tuberculus in the structures, and you can see the pellets, the mycotoxin pellets. The lights are adjusted, so you can see the mycotoxin pellets. And so this is the fibrous structure of the Candida fibrata or Candida nigros. This is the other micropellets or the tuberculus. This is the microscope focused, and you can see the tuberculus. So this is in the different layers, so it is little bit hazy, but the tuberculosis are present. The microscope is constantly adjusting its fluorescence, and you can see the tuberculus and the fibrata. This is the fibrous structure, the long tuberculus and the fibrous, and this is the other parts of the slide which shows the minute tuberculus the consisting of mycotoxin. So it consists of innumerable mycotoxins. Many mycotoxins are present, so the magnification is again getting increased to 200x magnification, 200x, and you can see the tuberculus is better. So here is the dark field mode. The background is darker, the microscope is again focused, and you can see a good resolution picture. So this is parts of the tuberculus, the Candida fibrata or Candida nigros fungus. So you can see the mycotoxins inside, the full of mycotoxins, and the microscope is again magnified, the image is again magnified, and this is again 400x, and you can see the tuberculus is better. So these are the pellets or the tuberculus, the mycotoxin consisting pellets which forms the tuberculosis, and this is the fibrata or the Candida nigra fungus. This is the condition of the mango, the rotten mango, the brownish mold which we have seen. This is the fluorescence image of that brownish mold. So these are the micropellets which consist of mycotoxins. So this is the mycotoxins of the Candida fibrose nigro, so you can say the Candida fibrose. So these are the mycotoxins consisting of 7 mycotoxins in total. The other peaks are of solvents, so too many peaks are there, so you don't consider the too many peaks, all the peaks. Only the 7 peaks are considered, and these consist of 7 mycotoxins. Among them the xanthotoxin is present. These lower peaks are not so very important. These are the lower peaks are there, but presence of xanthotoxin is also found in these lower peaks. but xanthotoxin is also available in the high absorbance peaks. So total 7 mycotoxins are present in this fungus, including xanthotrem, moliniform, aflatoxin, and vomitoxin. Also macrolatic lactone and is also present. So this is 7 mycotoxin, a dangerous fungus.